Climate change is one of the most controversial subjects in modern times. Today, I'm talking with Dr. Ned Nikolov, a climate scientist with a Ph.D. from Colorado State University. He has spent more than 2 decades working on ecological modeling and developing applications for predictive fire danger, but his journey into climate science took a turn in 2010. Recently, he posted charts and data online exposing deliberate manipulation of climate data by the International Panel on Climate Change. While IPCC scientists and other reports and even video footnotes on platforms like YouTube suggest that greenhouse gases are causing Earth to warm, the actual data shows the real driver of global warming is an increase in the Earth absorbing solar energy, not human activity. All right, and Ned, thanks for joining me today. I appreciate it.
You're welcome. Thanks for having me.
I came across you and your page through a series of posts you had recently about climate change and the International Panel on Climate Change deliberately manipulating climate data, and I found it very interesting. Before we jump into exactly what you said, because I want to give people an idea of who you are and what your background is, so kind of give me just an idea, take me through the background. Like, how did you get involved in climate science? What are your credentials, et cetera, et cetera? I know it says online you're a PhD, but kind of walk us through that.
So I have a PhD from Colorado State University, and I got this in 1997. It was in ecological modeling. So I've been working with weather data and ecosystem processes for all my career, basically. But for the last 24, 25 years, I've been involved in a project that is developing applications to help the firefighters predict the fire danger. And those applications are based on weather forecasts. So we call it fire weather, okay? And I was in this project as a working individual, developing, the website and supporting other things. And about 2010, I think my supervisor, the person who supervised the project, he retired, and then there was an opening on a position. I applied, and I was hired in his place, so to speak. So I've been managing this project of fire weather since 2010. So that involves working with a lot of weather data, real weather forecast, real data, and also the climatology, because some of the applications that we develop involve a lot of climate data. So the climate science itself, I got involved out of curiosity in about 2010, and that was the time when the Climate Gate came out. This was some leaked emails. Emails actually were hacked and stolen from a server in England, and they show the communication between top climate scientists on different issues. And those emails, because it was internal discussion, between them, they didn't know, of course, at the time that eventually those will be hacked and become public. So they were talking among themselves, and it was clear that they were, in some cases, they're trying to hide information. In other cases, they're trying to stifle, opinions that they don't like, in the peer-reviewed literature. So that whole thing, and there are a number of books actually now that are published with those emails and discussions about what it means and so forth. So it's not something that, it's in the gray literature. Actually, you can go on Amazon and Google ClimateGate, and you probably get a bunch of books, that talks about that. There was an investigation in England, and I think there might have been one here with Congress, but basically everything, there is nothing wrong, they're just discussing science, blah, blah, blah. But what I've read, it raised a bunch of red flags for me, because I thought before that the science was settled. And in fact, I was a firm believer in the greenhouse theory, the climate theory. And I used to even talk to colleagues that had different opinion. They were not scientists, but for political reasons, whatever, they didn't have this opinion that the climate theory is correct, or, the projections are correct. So I would argue with them, and I say, you have to be crazy. There are thousands of scientists looking at this. This IPCC report, it's not possible that those people will be wrong. So I was entirely on the other side until this Climate Gate came through, and then I got curious, because if the science is settled and everything is supported by data and so forth, you should not have this kind of a situation where they're trying to hide things, right? You just, they were trying to get away from FOIA requests, that people file for data and stuff like that. They would not honor them. They would not provide the information. So that kind of raised a lot of red flags for me. So I thought I'm going to look at the science and the physics, and not really interested in politics, right? Because politics is politics. I mean, you cannot put your thumb on politics, right? Everybody has an opinion. But when it comes to data and physics and physical laws, that's a different story, because there you cannot have an opinion. You're either wrong or you're right, depending on what you believe and how the data is supporting that or not supporting. So I started looking into the science. I started reading papers. I had some questions preliminary that I didn't have answers for, and I was curious about. And I thought, after a few months of reading, I'll probably answer those questions for myself, and that'll be it. Well, 6 months later, I had more questions than answers, because I started seeing things do not add up in the physics, in the theory, do not add up. Then I started thinking about, why is that? And so, in other words, there has to be an answer to those questions, physical answer. And so I started actually looking into new data, NASA data, and so forth. And then I discovered what we published in 2017 after a lot of ordeal with reviewers and journals and so forth. But we published a paper in 2017 that actually describes a discovery that we made that was based on NASA data. And the discovery base was that we used the planetary data from NASA, not just Earth, but other planets as well, that have hard surfaces, like rocky surfaces, not the gaseous giants like Jupiter and Saturn, but the ones that have moons and planets that have surface, like Venus, Mars, Earth, Titan, those moons. So we got those data. I searched a lot of literature. I got the best data that I could find, and those data, we did objective analysis on them, and we found a relationship through all these planets that explains the thermal effect of the atmosphere. And this relationship showed that this has nothing to do with greenhouse gases or the amount of greenhouse gases in different atmospheres, because the atmospheres of those planets is very different, right, compared to the Earth, very different. And yet all the planets of those different atmospheres and different distances from the sun, they all line up on one curve. And this curve was described by the pressure, total pressure. So knowing the thermodynamics and the physics behind it, I realized that what we have discovered is a kind of a macro level physical law, like on a planetary level, not something that you can measure in the laboratory directly, but you can have the data across a number of planets to actually see this relationship. So it was a beautiful curve that all the planets came on this curve beautifully, and the result was that the atmosphere warms the surface of a planet. Doesn't matter Earth's atmosphere or another atmosphere, not because of the greenhouse gases, but because of total pressure of all the gases. So it is a pressure phenomenon, not a phenomenon that relates to the radiative properties of individual gases. Very different view. I don't know if you can get it, understand the difference. But basically, the composition of the atmosphere is irrelevant. What we found is that what matters for the thermal effect of the atmosphere, how much the atmosphere makes the Earth, the planet warmer beyond what the sun provides. So the sun provides the radiation, but then the surface of the Earth, has been known for about 200 years, that it's warmer than if you didn't have any atmosphere, okay? A lot warmer. And this additional warmth actually comes from the pressure in engineering and in thermodynamics. It's known as compression heating, okay? So the example would be if you go up in a mountain or get on an airplane and you fly in the middle of the summer at 30,000 feet. If you look at this is normally international flights, but they give you the weather, like the temperature on the outside, and it's like deep sub-freezing, right? In the middle of the summer at 30,000 feet. Why is that? Why it gets colder as you go up in elevation, right? Well, that happens because the pressure drops. And when the pressure drops, the temperature drops with it. So that's an example how pressure impacts the temperature. A vivid example would be, and you can see pictures of that. For example, some peaks, mountain peaks like Kilimanjaro in Africa, like it's right on the equator. If you look at pictures of that, in the foothills, you have tropical vegetation, elephants, and so forth. And at the top of the mountain, you have glaciers. It's cold, but because it's about 6,000 meters above the sea level. That's because the pressure is much lower there, which is why it's cooler. So those are examples that, pressure actually is the one that creates the thermal effect, and the composition of the atmosphere does not matter. And that came also from our analysis of the NASA data. So that was a big revelation, because it doesn't matter how much carbon dioxide you have or you don't have. What matters is the total pressure, right? So then all the attempts to reduce carbon emissions, because they want to prevent a further warming of the planet, it's just a futile exercise, because the carbon dioxide is 0.04% of the atmosphere, which is so minuscule. If you remove the entire carbon dioxide from the atmosphere, the average temperature on the Earth will not change. There will be no plants and no life, because carbon dioxide is plant food, right? So the ecosystems will die for reasons that there is no food, so to speak. But the climate will not change. And so, that was the big revelation. So explain your question.
Yeah, no, I thought you did a great job explaining it. I mean, this is obviously your wheelhouse. You'd be able to explain it far better than I could. I do want to, and that makes a lot of sense. And I think for people with a basic understanding of this that don't have an agenda, there have been some suspicions that was the case for some time in some way. Your post, I think, seemed to reference an additional factor that plays into this. I'm going to actually read your tweets real quick, and I'll put them on the screen so people can see.
Right.
The first one that I flagged, it says, while working on a paper using Cirrus satellite data, I discovered that the latest IPCC report grossly misrepresented Cirrus observations of reflected solar and outgoing, I'm assuming that LW is light wave radiation?
It's long wave.
Long wave, okay. Outgoing long wave radiation.
This is thermal radiation, yeah. Mm-hmm.
Okay. In Chapter 7 of the report, Figure 7.3 shows inverted trends of reflected solar and long wave fluxes, misrepresenting, and then the other tweet you had in this thread, misrepresenting the Cirrus data in this manner implies a deliberate fraud committed by the lead authors of the report, of Chapter 7 of the report, rather, because the trends of reflected solar and outgoing long-wave fluxes have been inverted via multiplying the original series anomalies by -1. This cannot be accidental. So do me a favor and sort of just like translate that into English.
Okay. So Cirrus is a project that has sensors. Basically, this means cloud and Earth radiant energy system, okay? And Cirrus is an acronym for this project. And what it is, it's a bunch of sensors that are on several of the satellites that are orbiting the Earth. And what they are measuring is radiation coming from the Earth. This is both shortwave radiation, which is like solar radiation, like the one we can see. And there is also solar radiation we could not see. It's called near infrared. But it's basically shortwave means solar radiation. And then they also measure long wave radiation, which is thermal radiation. That is the radiation that the Earth emits itself because it has a temperature above absolute zero. Any object in the universe, that's a physical law, that has a temperature above absolute zero, emits long wave radiation. So, but by measuring those two fluxes, also the Cirrus measures also other things like the cloud cover, the cloud temperature, and so forth. But those are kind of the main fluxes that they measure. It gives you kind of the pulse of the planet in terms of climate, what's happening. Because the shortwave radiation that's coming from the Earth, it's not emitted by the Earth, but actually it's reflected. So the shortwave radiations come from the sun, it hits the Earth, and some of it gets reflected back to space. And the radiation that's reflected back to space is basically lost to the climate system because it could not affect temperature, it could not do anything. It just it's like on a mirror, reflects back and it's gone, right? So the shortwave radiation that's coming from the Earth is all reflected. The long-wave radiation is emitted all from the Earth. And the long-wave radiation gives you information about how fast the Earth is cooling and what is the temperature on the surface, because the long-wave radiation that you measure on top of the atmosphere, it is a function of the changes of the temperature on the surface. Now, the shortwave radiation that is reflected, the portion that's not reflected is absorbed. So the absorbed radiation actually by the Earth and the atmosphere is the one that fuels the climate system, is the one that drives everything, because that's the energy from the sun. Without that, everything will be frozen. There will be no life, nothing on this Earth, right? I mean, if you turn off the sun, literally within like 48 hours, everything will be frozen. If, in theory, of course, it will never happen. But I'm saying in theory, the sun is so powerful that without the solar energy from the sun, we will be frozen in no time. That's the message. So, right.
Yeah, I was going to reference another post you have in reference to this, because you said that. So, I mean, we have a very fierce and vociferous climate lobby throughout the entire world at this point. You've got activists, we've got politicians, we've got people on the news fear-mongering, and we can get into what the motivations might be for some of the solutions, but I want to reference something that you said in reference to what you just commented on. And you noted that all warming of the past 24 years, so more than 2 decades, was caused by an increasing uptake of solar energy into the Earth because it's reflecting less. That's what the data show. Right. So this would seem to indicate that the real reason for the Earth's warming, long term anyway, has nothing to do with man-made climate change or fossil fuels or greenhouse gases, but it's just simply the Earth is absorbing more energy from the sun. It completely blows apart the political narrative.
That's exactly right. And this is not my theory. It comes directly from satellite data that NASA has provided. It's on their website, right? So when you look at those data and you analyze them properly, and we have done this in a very long paper that was just submitted yesterday for publication. I don't want to say which journal because I don't want to jeopardize the whole situation, because people that don't like what we are presenting, they have the powerful lobby, they have the influence, if you want, to stop publications and even close and shut the journals. I mean, that happened in the past. They fire editors. I mean, we're talking about major. It's not a conspiracy theory. That's the reality. Anyways, but we submitted a paper that is 31 pages long, and today I actually posted on X. I posted the abstract just of this paper without any indication which journal it is I submitted to. But this paper goes through a very detailed analysis of this serious data, satellite data that comes from NASA, and it shows that basically through math and equations and so forth, and through correlation between the temperature, surface temperature records, and the satellite data, it shows that the entire warming of the last 24 years, the serious data started being measured in March of 2000. So from March of 2000 to the present, we have a continuous record. It's actually on a monthly basis. And it shows this entire period, we had substantial warming, right? But the entire warming is absolutely 100% explained by the increased amount of solar radiation that the Earth has absorbed. That's because of the reduction of the cloud cover. And this increased amount of solar radiation has been documented in a number of papers that are not ours. And some of those papers are written by the Cirrus team, the people that manage the Cirrus data of NASA, okay? The thing that they have not done explicitly, and which we have done in our paper, is that they have not assessed what is the contribution of this increased amount of solar radiation on the total warming. In other words, how much is caused by the greenhouse gases, how much is caused by the sun, right? And after we did our analysis and we got the result that everything is due to the sun, 100%, it became clear to me why the previous papers that have been published only talk about increased absorption of solar radiation, but do not give any number, what that means for the warming, right? Because if they say what it means, that will be the end of the anthropogenic global warming story, right? And the people at IPCC, they probably realize that very well, because in this chapter that I mentioned in my tweets, they have a section that talks about top of the atmosphere radiation fluxes, and they refer to serious data. But in that section, they don't talk anything about trends, like is it going down, is it going up? They just talk about that the serious data, have measured this, and they have this graph that the figure is 7.3, and this has three panels. And those three, on the top panel, it shows the reflected radiation, solar radiation. The second panel shows the thermal outgoing radiation, and the third one shows the net flux. And since I already worked with the data and I know the graphs because I put the graphs together, I analyzed them, and I'm very familiar with the trends, right? I know them by heart, so to speak. So I was looking at the IPCC report for some references, because I want to refer in my paper, just reading what they're saying, so I can quote them correctly. And when I glanced through this figure, I realized, I said, those trends are upside down. This is not what the data show. They're the exact opposite, right? And we're talking about two trends: reflected solar radiation and emitted thermal radiation. So the reflected solar in the real data is going down. That means the reflection is becoming less and the Earth is absorbing more sunlight. In the IPCC report, they multiplied the time series by -1, so made from a negative trend, they made it into a positive trend. So in the IPCC figure, it goes up. The same data, it just flipped over, right? The same thing happened with the long wave. Long wave radiation in the original data goes up, and that makes sense because any object that's getting warmer, it starts to emit more long wave radiation. That's a physical law. So you would expect that radiation coming from a warming object will actually increase, right? That's what the data show. The long wave radiation in the real data is showing upward trend, right? In the IPCC, it's the same data flipped over by multiplying by -1. It shows a negative trend. Now, it's very important to realize that according to the greenhouse theory, when greenhouse gases increase, what they do, the claim is that they trap heat. Now, trapping of heat in an open system like the atmosphere, it's impossible because it doesn't have any roof on it. I mean, imagine in the middle of the winter, if you remove the roof of your house, you expect that the heat could be trapped somehow in the house? No, because it goes away, right? The atmosphere has no roof. So there is no trapping going on. You could not trap heat, right? And so because the theory says that when you increase greenhouse gases, you should be reducing the amount of thermal radiation going out. That's in the theory. It's very bizarre, it's absurd claim, but that's in the theory. By inverting the trends from the real data, they actually are showing this effect in the IPCC report, but they don't talk about it. They don't emphasize it, because if they say, oh, the trend of the long wave radiation is negative, and the reflected radiation is positive, that will immediately raise a red flag, because they have in papers published before the IPCC report that actually says the exact opposite, right? So people will immediately recognize that something is wrong in the statement. So I think they deliberately did not talk about it at all, just splash the figure there, right? Show the figure. And because the figure, a picture is 1,000 words, right? So people open the report, they look through the report, and they may not read every single sentence in the text, but they look at they say, oh, wow, look at this, so they will remember that. So the whole thing is done, I think, very deliberately, and then there is a peculiar sentence in the caption of the figure, and I can, let me read it here, I have it right here. A very peculiar sentence that says, in the caption says, all flux anomalies are defined as positive downwards, consistent with the sign convention used throughout this chapter. Now, this is a little bit technical, but it's important to point out that anomalies, so what is the anomaly? Anomaly is basically the departure from an arbitrary reference value. So if you have a time series of, say, of flux or temperature, whatever it is, going upward direction, right? You can pick a value like in the middle of that series, and then say, okay, this is my reference value, and then you subtract all the other values from that value, right? So then a part of the curve will be negative, a part of the curve will be positive, right? So you get positive and negative, right? But so the anomaly, the way it's calculated, has nothing to do with the direction of the flux. Direction of the flux is totally irrelevant. It doesn't even enter the calculation, right? So so that's one thing. The other thing is that when you calculate anomalies, it doesn't matter what the reference value is. You can pick any reference value. So you can get positive anomalous, negative anomalous, doesn't matter. The trend of the data never changes. The trend is always the same as in the original data, right? So if the quantity, like temperature or flux, is going up, you calculate the anomalies, it's still going up in the same rate. It's not going down all of a sudden, right? So this sentence that they have in the caption there is very peculiar because it's nonsensical. It refers to the direction of the flux, how they assume that the flux downwards is positive, which has no bearings and no relevance to the actual calculation of the anomalies. So why you put a sentence like that in the caption when it's totally irrelevant? I think it's to kind of confuse people and create a plausible deniability, like, oh, look, we actually had a different convention, and that's why we're getting this result. No. You could not get this result inverting the trends by by talking about direction, because that has nothing to do with how you calculate the anomalies. Is that clear? I don't know.
No, yeah. And I mean, the question I have then is, I think what naturally follows is if it's proven that the IPCC is intentionally lying about climate data, which it certainly appears they are, I mean, what are the implications here?
Well, the implications are big, and I think this one graph, if it's exposed to the world and people actually understand what they have done, I think it has the power to collapse the entire narrative, the anthropogenic global warming narrative. It can collapse it. Because why? Because if the reflectance have actually decreased, in other words, the absorption has increased, right? If that's the case, and they don't address this in the report, immediately opens the question: what is the contribution of the solar radiation in this warming? You're not talking about this at all in the report. Like, there is zero discussion about that. Everything is the same greenhouse gases, right? And the other thing is that the long wave radiation, it was also going up, and they made it going down because that fits the theory. That's directly it says it's fraudulent, right? So by actually having those two graphs upside down, and the other thing is that they are showing that those graphs being upside down, they are matching the output from climate models. Well, if the climate model output is plotted correctly, which I think it is, that means that in reality, the climate models in reality going in different directions. So that means the models are just being shown that they have no skill. That's the technical term. Models have no skill. And basing all policies and energy policies and turning the whole world upside down because of the climate model projections, because this entire climate thing is driven by models. People have to understand that it's not driven by observations. It's driven by results and projections from climate models. So if the models are fundamentally wrong, the whole thing falls apart.
Right. I mean, with models, whatever variables you put in determine what the output's going to be. So you could
well, that's not exactly right. This is not exactly
okay.
right. I mean, those are very complex models. They're very nonlinear.
But so generally, though, there's no way to design a model to produce an outcome that was pre-desired?
Well, yes, you can do that, but the climate models are so complex that they have a huge list of parameters, and people have been playing with those parameters, and they adjust, how the clouds are formed. It's mostly basically the cloud physics, and that gives you a little bit different output, right? But overall, all the models project that with increasing the CO2, you have more warming, right? The warming increase. And that's because all the models share a common algorithm, which we have actually analyzed, and it's not published yet, but we found that there is an algorithmic error in those models, right? And this algorithmic error is producing this artifact that increasing the concentration of a small trace gas, which is very minuscule, causes the temperature to increase in the model. That's not happening in reality, absolutely not. But the models have an algorithmic error, and basically this effect of CO2 causing warming is nothing more than a violation of the first law of thermodynamics, which is also called the energy conservation law. You know, in physics, there are some fundamental laws, and the law of the first law of thermodynamics, where it says energy could not be created or destroyed. So basically, those models, because they have this algorithmic error in there, which I don't want to describe this because it's very technical. I know what it is, but it basically, the effect is that they create energy out of nothing in the model, and this is being attributed to the CO2. And it's just false. It's not right.
And I've seen other information that suggests, and tell me if this is correct in based on what you understand about this topic. I've seen some research that suggests that temperature changes, warming in particular for this conversation, actually precedes CO2 changes. So there can't be a causal relationship between the two because the warming comes first. Is that accurate?
Yes, that's accurate in the long term. Like if you look at the ice core data from Antarctica, where you have they have reconstruction of temperature, both temperature and CO2. And there you can see, because this is a large time scale, this is like the ice core in Antarctica, like 800,000 years record, right? And the time step of the record is several hundred years from point to point. And, when you go to earlier portions of the record, it's actually like 1,000 years. But there you can clearly see, and this has been known for a long time, that there is the CO2 lacks the change in temperature anywhere between 400 to 4,000 years. So the lack in this time scale, the lack of the CO2 behind temperature is greater than a human generation, much greater, right? And so this is something that is known, and the IPCC even have addressed it in one of the reports, and they come up with some convoluted explanation that orbital changes, they cause the initial change in temperature. The temperature starts changing, but then the CO2 acts as a feedback and amplifies that, and all this story. But no, through the entire ice core record, the CO2 always is behind temperature by hundreds to thousands of years.
Okay. And then so for our conversation here now, I mean, we've been talking about the IPCC and their data being manipulated, just errant at best case scenario. That leads me to suspect that if this organization is misrepresenting climate data for reasons that we haven't tried to specify just yet, wouldn't it suggest that other agencies are also manipulating climate data as well?
Well, you can assume that there has been some attempts to manipulate data. To what extent have been done? You have to look at particular cases and actually analyze and come up with conclusive with conclusions that way. You cannot just have a blanket statement. Oh, if the IPCC manipulated me, so the other agencies are doing the same thing. It's a mixed bag. There is a lot of good quality data in climate science, but some of those data are being ignored or being misinterpreted in a way that is convenient to the dominant narrative, right?
So have you personally seen something like this with any other agency?
Of manipulating the data? Yes, I mean there are famous examples. Jim Hansen, who used to be director of the NASA Goddard Institute for Space Studies, he's now retired for a long time. I think he retired 2013. But there are some famous cases where, specifically the temperature record for the United States, where, I think it was in 1999, he even had a paper published. And I have a copy of that on the NASA website, where he talks about that in the U.S., the 30s were warmer. The 1930s were warmer than the late 90s, right? And he speculates that the overall global warming that has been affecting the world apparently is not affecting the U.S. the same way. This was in 1999, okay? 5-6 years later, all of a sudden, and people have done animations with this graph, previous graph and the current graph, previous graph and current graph, like flipping over. And you can see that, the data has been changed. What happens is that the past has been cooled and the current data has been warm, has been increased. So then the trend, all of a sudden, is going up, right? And the difference that, and the fact that the 1930s were much warmer than the 2000 was obscured because of this change, right? So this is one famous case that is well known. Actually, you can find clips online with the two temperature records, earlier and later.
So I'm sorry, go ahead.
But, again, you could not place a blank statement and just say, well, IPCC manipulated that. I believe personally that, the IPCC report is a gigantic piece of, report, right? It has thousands of pages. So the one that we're talking about, the physical basis of climate, it's well over 1,000 pages, right? And so there are so many people involved. Like this chapter 7, it has 2 lead coordinating authors, and it has 10 lead authors and a bunch of contributing authors. Like the list of contributing authors is probably, 25, 30 more, maybe more. But the lead authors are the one that are writing the chapters, and people have different pieces of, assignment, basically. They write, and then the coordinating authors have the responsibility to assemble all this stuff in one package and make sure that things add up, right? That there's no discrepancies, right? So I believe that this graph of altering the trends from the series data that's in the IPC report was probably made by a small group of people, maybe even 1-2 people. They put it in there, and the atmosphere in the IPCC is such that they don't question each other's work. I've seen videos with people that have been selected to be coordinating authors, and they are normally majority of them, not all of them, but majority are young people, and for them it's like reaching heaven. You're being honored to be a coordinating or a lead author on a chapter of the IPCC. That's a big deal, and they talk about like how flattered they are, right? So the last thing on their mind is just to question their colleagues. How did you make this graph? Does this make sense? There is no discussion about this. Is my interpretation. I've never been in IPCC circles, right? But I think they just don't do that. They just accept that everybody there they're of the same opinion, like-minded people, right? And so everything that comes there, it has to be gold, and there is no really questioning. And I'll give another example. This graph is not the only problem in chapter 7. There is another big problem, and that is there is a section that talks about the accumulation of heat in the Earth system. And that's based on energy imbalance, and the energy balance has been measured by satellites and measured also by surface observations or derived from surface observations. But anyways, they integrate this energy imbalance over time and space and come up with those huge numbers. And they say this is the amount of heat that the Earth has accumulated, right? And then there's a discussion about where this heat goes. Well, they say, only about 1% remains in the atmosphere. 99% goes into the subsurface. Now, the heat is supposed to be trapped in the atmosphere by greenhouse gases, but then somehow it's been converted into the subsurface, and 90% of that goes into the ocean, 8% goes into the glaciers and the land, and only 1% remains in the atmosphere. Well, but then there is another section that talks about the effective radiative forcing. This is actually the forcing that arises from rising concentration of greenhouse gases. And this forcing actually gives rise to the energy imbalance, which gives rise to the whole heat accumulation. The section that talks about the radiative forcing, it basically says that the radiative forcing that they calculate, it's a calculated number from models, from the 1750 to the present, is just enough to explain the surface warming. In other words, this section does not give any indication that something is being stored into the subsurface, right, into the ground or into the ocean. So this is a major logical inconsistency in the report itself. One chapter says that only 1% of the heat remains in the atmosphere, and the other chapter says, well, this relative forcing is just enough to explain the entire surface warming, and nothing is left for storage, right? I mean, we're talking about, it's not like a 10% discrepancy, it's a 99% discrepancy, right? So what I'm saying is that, to me, the coordinating authors did not do their job and do diligence to actually look at the content of the individual sections and say, does this make sense? Do they actually, one thing being said here, does this actually add up over here? They have not done this apparently, because otherwise you would discover this is so obvious. You discover this discrepancy, right? So, but I don't know. I think every case has to be addressed individually. You could not just have a blanket statement. Blanket statement is a dangerous thing. This is done in politics a lot. Well, if this is happening here, that means over there. Well, you can say probably there is things going on elsewhere of the same kind, but unless you discover something and actually have proof, you could not be certain. And it's not a good idea to push that idea.
Right, and that's certainly fair. That is definitely fair. Yeah. But let me ask you this. So in light of what you just presented, I mean, how can the scientific community and even just interested parties, we've talked about lawmakers, activists, how can, let's just say, the international community ensure the integrity and the transparency of climate data going forward?
Well, I would say the first step is this: if something like this gets discovered, like what I discovered, and I think when you talk to scientists, and I try to talk actually to some of the serious scientists, actually the head person of the serious data, and I presented this problem with the inversion of the trends, he didn't have an explanation. In fact, he stopped talking to me. So the first step is, like, when something like this is brought up, there has to be an acknowledgement. There has to be, noise has to be made in the media. I mean, the mainstream media will never make noise about something like that. If I go to CNN or say, I discovered this, would you report on that? What do you think the result would be? They're going to report the next day? Hell no, right? Because everything is politically biased. In fact, I have sent this information to some scientists that are not involved in the IPCC, and I sent them to some managers in the Forest Service where I work, just for information. I said, this is what I discovered, and there has been no response. In other words, people don't want to even talk about it. And the funny thing is that some scientists, when we have a communication with them on a different related topic, and then I bring up this issue, and I said, look, I discovered this problem with the inversion of the trend by IPCC. They stop talking to me immediately. There is no more reply. It's like it's their fault. It's like they're guilty of something they don't want to talk about. It's like a kid, like, I don't want to talk about this, right? But it's not their fault because they're not the one that did it, right? So it's a funny situation that people that are involved in that kind of very much supportive of the IPCC and believe in IPCC and all that, and as an institution, when they face a fact like this, they feel so uncomfortable. It's like you attacking them personally, and they decide to stop communicating with you. It's a funny situation. I think the first step is to get over this technological barrier, if you will. If there is a problem, you should be talking about this openly. The media should pick up on it, and then everything becomes transparent. And then, the next time they're trying to have another report, the people that are writing the chapters will not do this again because they know what the consequences are, right? So that's this is an explosive information. I mean, it could take down one of the world's largest religions, climate change. I'd imagine you're going to get a lot of pushback. I mean, have you gotten any severe pushback on this just from what you've posted publicly so far? No, I think all the comments that I've seen so far, actually, they're all supportive. People are really excited about, interested in this thing. And I've not seen a pushback. Now, I'm planning to have a formal note, like a little, what they call it, a communication note, not a full paper, but like a note that I'll try to send to publish in a peer-reviewed journal about this, and it will be presented in form of a question like, how come, here is the real data, here is the publication that other publications that actually people acknowledge that the reflectance have been going down and the long-wave radiation has been going up. And here is the graph from the IPCC, which shows the exact opposite. How we're supposed to interpret that and what's going on. You basically ask the question, right? Now, I don't have illusions that I can easily publish something like that in the peer-reviewed literature, because you can imagine, you probably don't know, but the censorship there is pretty severe. And but I'll try, because if not, I'll put it on a blog somewhere. I have access to blogs that I can put in a blog so people can see, and it'll be explained with graphs and everything in a technical way, so there is no questions, with all the references there and so forth, with sources basically, right? So that's what I'm planning to do, but we'll see.
Well, Ned, this is great information, and I hope it gets seen by a ton of people, because again, we're having so many conversations about this topic right now when it comes to climate policy. We've got Agenda 2030. We got people trying to put everybody in electric cars. I mean, we don't have enough mineral resources to put in everybody into electric cars. Definitely not by the year 2030. So I hope I hope it sparks additional conversation and sort of moves things forward. And
my hope is that
you
too.
have an important role in that.
I want with this kind of information, people to start asking questions, including scientists, and be critical of the institutions. You could not assume that because it's an international body, and that this is flawless. You just could not. We're all humans. Humans have biases, and when biases are accompanied with a good paycheck in order to present a view or to represent or defend a view, and for that you get a good salary, good promotions, and so forth, that's even more incentive not to talk the truth, right? So there has to be transparency, and people have to be open about this. And this openness will actually create an atmosphere where you could not do those kind of lies or frauds basically anymore, and then people will get in line. I mean, it's like a law enforcement. If you especially in the United States, if they have tried this, you defund the police or you stop to prosecute criminals, and what happens? The crimes go through the roof. Because people see that it's an opportunity, right? They see that there will be no punishment. So it is the system that keeps in check, people basically. So you have to have a system that is open and transparent, and those things are not allowed and will not fly basically, in society.
All right, and real quick, for anybody who wants to get a hold of you to maybe share information or to yell at you, what's the best way to reach you, man?
Well, probably the best way is Twitter, direct message. I mean, of course I have email address and so forth, but I don't want to get flooded with emails. But on Twitter is, direct messages probably will work fine. Awesome. I'm open to all, I think there is an option there. You can have direct message only people that follow it, but I think mine is open to everyone. They can send me a direct message.
Nice. Awesome. Well, Ned, thanks for joining me today. I really appreciate your time. Good chat.
Sure. Thank you very much.